30 divided by negative 6 is negative 5. And we'll have h to the 6 minus that negative 3. But what happens when I subtract a negative? It turns into a positive, so we should have had negative 5h to the 9th would be my complete answer. Are we good with that? Okay. And then our final one, we can't actually do 14 divided by 14, right? We can't actually do that division because it turns into a decimal. If you plugged in your calculator, it came out to a decimal. So what we did instead is we simplify this fraction. Well, that fraction, 2 goes into 4 twice. 2 goes in 14 7 times. Does that make sense? We're good with simplifying fractions. If you haven't done that for a while, that's simplifying fractions. All right, then I have c to the 11th over c to the 8th. Remember, it's 11 minus 8, which would be c cubed. And we have 2 ways to do this next one. What's anything divided by itself? 1. So what's d to the negative 3 over d to the negative 3? 1. And that's much easier than messing it up because it's much harder to do it kind of the mathematical way because the mathematical way is, oh, this is d to the negative 3 minus a negative 3, which turns into the 0. But it's easier if you just said that was 1. Think of the much less work you have to do. Sean, do you mind picking up your head so we can get these correct? So that would be 2 over 7 times c cubed times d to the 0th, but that's just 1. I'm going to shoot that c cubed to the... This is fine. This is fine for your answer if you wanted it. Okay? But I'm going to go ahead and put that c cubed on top because if it's positive, it goes to the top. And so we're going to have 2c cubed divided by 7. Yep. Are we good? Good, good, good. Yeah.
Why would 7 just be by itself?
Why would 7 just be by itself? What would be next to the 7? Well, c to the power of 3 goes to the top because it has a positive exponent. If this was c to the negative, then it would join that 7 on the bottom. So if you have a negative power, you go to the bottom. If you have a positive power, you go to the top. Okay? Positive power, top. Negative power, bottom. We good with that? Okay. Let's just push the lesson, then we'll look back at that pink sheet, okay? Okay, today's lesson... Oh, actually, let's go over homework questions. Sorry. Oof, oof, oof. And... All right, yeah. Number 15, sure, let's take a peek at it. 15 looks like we have negative 3a to the 4th times negative 16a to the 7th. Now remember, PEMDAS tells us that if we have a division sign, we have to do everything on the top and simplify the bottom before we actually do our division. So we actually have to do this multiplication up here. This has to be the first thing I take care of. All right, now we're going to multiply things we can multiply together. So I'm going to do the negative 3 times the negative 16. Well, that's a negative times a negative, so I should get out a positive, right? And what do I get out if I do 3 times 16? Positive 48. Malia's checking it as well. Did you get positive 48? You agree with positive 48? Okay. Now we're going to have a to the 4th times a to the 7th. When I multiply the same base, what do I do with my exponents? When I divide, I subtract. When I multiply, I... add. Multiplication, I think, is an addition because multiplication is you add, 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 add. Division, you take away, so that's our subtraction one. That's kind of how I remember it. Okay? So we're going to add. So if I have a to the 4th times a to the 7th, what am I going to come up with? A to the 11th. So we'll have a to the 11th. And that's going to be over 8a to the 6th. Well, that means we need to simplify a fraction because I bet you if you plug 48 divided by 8 in your calculator, it doesn't come out. Oh, it does come out. It does come out. I'm sorry. How many times? Let's plug it in. Let's do 48 divided by 8. See if it comes out.
Does the question become a multiplication problem as soon as it becomes not negative?
As soon as it becomes not negative? Well, It was a multiplication problem because the top was multiplying. And when you do multiplication, you multiply your numbers, and then you multiply your bases. Okay? So we just multiply the top because that's what we had to do. It had nothing to do with the positives. What did you come up with? 6. So we have 6. And then now remember, if you multiply, you add. When you divide, you subtract. Did you agree with that? So if I multiply as 4 plus 7, that gives you 11. Now we're going to do 11 minus 6, which is going to give you 5. So this will be a to the 5th, and we're done. Okay, so it's just breaking it apart into small chunks. Don't look at these complex problems. Look at each individual chunk. Chunk them. Instead of being, overwhelmed by all the different steps. Yeah, Campbell.
Can you do number 13?
I can do number 13. All right, 13 has 3k squared times negative 40k 18th. Okay. So we're going to go ahead and we're going to do what? We're going to simplify. Perfect. But how do we simplify? What is our order? Exponents. And we got a bunch of exponents, right? Okay. So what I'm going to do is I'm actually going to simplify. We got 2 things we can do. I'm going to go ahead and I'm going to simplify this fraction. That seems like the easiest thing. Make that a little more simple, okay? So let's simplify that fraction. So let's leave that 3k squared out there. Because I notice I have a negative 40 divided by 5. Remember, we have to simplify everything we can. Yeah.
It was negative 8.
It'll be negative 8. So we're multiplying by negative 8.
Oh, I forgot the negative.
Yeah, don't forget about the negative sign. Changes stuff, right? And then I have k to the 18th divided by k to the 6th. Who thinks they can do that for me? K to the 18th. Gabby? K to the 12th. Perfect. And now we change to a multiplication problem, right? So we had a division portion. Now we have a multiplication portion. Now we'll do that 3 times negative 8, which should be a negative 24. And when we do multiply, we add our exponents. So that's 2 plus 12, which would be 14. Campbell, do all the steps make sense? So we do each individual thing. Worry about dividing, then worry about multiplying. Dividing, we subtract. Multiplying, we add. Ethan, you've been waiting. Yep.
Can we do number 18?
Number 18, sure, let's do it. Number 18, remember, if we're doing a fraction, we should simplify the top or bottom first, right? So do we have work to do on the top and bottom? Yeah, we have work to do on both the top and the bottom. So let's go ahead and do the top first. Now remember, we multiply, they're all a chain of multiplication, right? So we're going to simplify things I can. So I'm going to do the 5 times the 18, okay? And 5 times 18, that should be 90, I believe. You can double check me. And remember, we do one thing at a time. We're doing multiplying. Multiplying means add the exponents. So I have a to the 3rd and a to the, there's no number there. 1, thank you. Don't put a 0 there, right? Because there's a 1 there. So that'd be 3 plus 1, which would be 4, a to the 4th. And we'll have b to the, what's negative 2 plus 2?
0.
0. So we have b to the 0. What's anything to the 0th power?
1.
So this is really just a 1 hanging out, right? And then we have it all over. Once again, we have multiplications. I'm going to do that 9 times the negative 1, which should give me a negative 9. I have a to the, notice we have a 4th, and we have to the 1st. So that's 4 plus 1 would give me 5. And then I have b to the 1st plus 3, which would be b to the 4th. You good with that? You sure? Okay. I just don't want to move too fast. And you're just like, where did you come up with that? So we have 1 plus 3, which is b to the 4th. Let's simplify some of this. Well, 90 divided by negative 9 is a negative 10. We have 4 minus 5. 4 minus 5 is a negative 1, right? You agree with that? So we have 4 minus 5, which is a negative 1. So we have a to the negative 1. And then we kind of have this 0 minus 4, which would be b to the negative 4. If it has a negative exponent, it goes to the bottom. If it has a positive exponent, it goes to the top. 10 is going to go to the top because it's not a fraction, right? It's 10 over 1. So we'll have negative 10 on top. A to the negative first goes to the bottom. B to the negative fourth goes to the bottom. And we have that as our answer. That was a little more complex, right? Because we had a lot of steps where also we get rid of the fractions and also we bring the fractions back in. We just got to do little bits by little bits. That way if you make a mistake, I can see what the mistake was and I give you as many points as I can. That's why we don't just write stuff down as answers. Yeah? Yes. Any other questions? Yeah. Number 17. Well, I got it up there, don't I? Okay, now remember, we simplify the tops and bottoms first. Nothing I can do on top. That's just one thing, right? So the top's going to remain. 20x to the 9th, y to the first. I'm going to put a first there so I don't forget about it. On the bottom, though, I have a chain of multiplications, right? So we're going to do that 6 times that negative 4, which is a negative 24. Now, this is x to the first, right? What do I do if it's multiplying? I have x to the first times x to the first. What do I do with the exponents if I'm multiplying? I add them. So 1 plus 1 is 2. So we have x squared. And then I have nothing to multiply the y with, do I? No, so that's just y squared. Now we do have to simplify this fraction. Yeah. How did I get y squared? They gave me y squared. I just didn't do anything to it. All right. Now just to speed through this, 20 divided by 24. 4 goes into both 20 and 24. So I'm going to simplify this fraction. 4 goes into 20 5 times. 4 goes into 24 6 times. So I have 5 over negative 6. Just simplified that fraction. Now we have 9 minus 2, because when we're dividing, we subtract. 9 minus 2 is 7. So we have x to the 7. And then we have y to the 1 minus 2, which is a negative 1. 1 minus 2 is a negative 1. If you have a positive exponent, it goes to the top. Negative exponent goes to the bottom. So we're going to have 5x to the 7th over negative 6y to the first. Positive makes it go to the top. Negative makes it go to the bottom. Okay? If you have other questions, awesome. I'm going to try to get through the lesson and we'll go back to those questions. I just want to make sure we get through our lesson and have plenty of stuff on there. But we should have time to go back to any other questions that you have. All right. So today's lesson is one more power rule. It's the only power rule we haven't learned. Remember, when you're adding like terms, the powers don't change. So let's talk about that real quick. So if I have x to the 6th plus 3x to the 6th. Now, we can just look up here. We don't need to write this down. We're just rehashing stuff. So let's just look at the board. If I did x to the 6th plus 3x to the 6th, how does that simplify to? Yeah, what else? Nope. Nope, not 1x. Definitely not 1x. Yeah. It would be 4x to the 6th. Because when you are adding like terms, you just add the number in front of you. You're just counting how many x to the 6th you have. I have 1x to the 6th plus 3x to the 6th. That gives you 4x to the 6th. So when you are adding, you just put the number in front. So 1x to the 6th plus 3x to the 6th equals 4x to the 6th. Now compare that to x to the 6th times 3x to the 6th. It would be 3x to the 12th. Because if we're multiplying, then we add and multiply. So really, this was 1 times 3, which gave me 3. X to the 6th times x to the 6th gives me x to the 12th. Then we did what we just did. If I have x to the 6th divided by, I guess, let's say it's 2x to the 6th divided by x cubed, we would have 2 over 4 turns to 1/4, but we subtract and we have x cubed, which could be just x cubed over 4. So when we add, we just do like terms. When we multiply, we add our exponents. When I divide, I subtract my exponents. Today, we're going to talk about raising a power to a power. So now I have x to the a to the b. If you raise a power to a power, you are going to multiply your exponents. Oh, I didn't give you the lesson, did I? Rehash. Multiply, add exponents. Divide, subtract exponents. When you raise an exponent to an exponent, you multiply your exponents, but it's going to look like this. X to the a times b. You may want to put that on your pink sheet as well, because remember, your pink sheet, we'll go back to your pink sheet, and we'll add it individually. But if you want to add to it now, that is your study sheet. That is your sheet to know exactly what to do when you see a particular problem. So when we have a power to a power, we just multiply our exponents.
Not the bottom numbers?
Not the bottom numbers.
So this is easy.
It can be. It can be also be very, very frustrating because it's a bunch of different rules that we have to put together. That's where it gets frustrating, right? Okay, so let's look at, so when we first learn the rule and we first do this, it seems easy, and then also we have like the complex ones that have all the steps, and that's when it gets complicated. All right, I have a squared to the 5th. That's a power to a power. So this is going to turn into 8 to the 2 times 5, which is going to equal 8 to the 10th. And we're just going to leave it as that. We're not going to plug in our calculator because I trust that all of us can plug in our calculator. We can put that little hat button or that roof button. That's not the thing we're learning. We're learning about how I can rewrite this stuff. All right, notice this one we have negative 15 to the 6th to the 3rd. Keep the negative 15 in parentheses.
So if it's negative, you always keep it in parentheses?
Always keep it in parentheses, yep. Until we get rid of it, like when we actually plug in our calculator or something like that. Okay, what power am I going to raise that to? How am I going to simplify that? It's to the 6th to the 3rd. What's that going to simplify
18.
to? Why 18? Someone besides you, because you have the answer correct. Can someone else explain how we got 18?
They multiply 6 and 3.
Because we multiplied the 6 times the 3. A power to a power means multiply. So I have 6 times 3. So we're going to have negative 15 to the 18th power.
Why do they put so many parentheses?
Because you need a parenthesis to hold on to the negative, and we need another parenthesis to raise it to another power. Every time you have something else happening to it, you have to add another parenthesis set to it. You're going to find in really difficult math stuff, there might be like brackets out here because we have to do something else outside of it. So every time you're doing something, you have to put parentheses to make sure it's organized and you know exactly what they're trying to do. Okay, so my next one, I have 4 to the negative 2 times the 2. What would that be? 4 to what power? Don't shout it out. Yeah. It'd be negative 4 because it'd be that 2 times negative 2.
Wait,
Yeah.
wouldn't the 4 be in parentheses?
Wouldn't the 4 be?
No,
Nope.
that-
We only need it for negatives. Because negatives, I want to know that it's negative 15 times negative 15 times negative 15 times negative 15. The 4, it doesn't matter if I have parentheses or not. It's still 4 times 4 times 4. But we have a problem with this one because I have a negative exponent. We're not allowed to have negative exponents. Can someone raise your hand and tell me how to turn 4 to the negative 4th to have it positive? Yeah.
1 over 4 to the 4th power.
1 over 4 to the 4th power. Perfect. Good with that? 1 over 4 to the 4th power? Otherwise, you have it wrong. Whoop. I guess I didn't put space for this one, but can someone raise your hand and tell me what 2 to the 4th to the negative 2 would simplify to? Really? To the negative 8. 2 to the negative 8. Now, if I put 2 to the negative 8th, would I have full credit on the test?
No.
No. Can someone walk me through how to turn that into a positive? Yes.
You do 1 over 2 to the power of 8.
1 over 2 to the power of 8. Perfect. Thank you. All right. I have 10 to the negative 3 to the negative 7. I want that to be simplified. What's that going to simplify to, that power? Someone new. I get that you guys have it. Someone I haven't called on. Yeah.
10 to the power of 21.
Of 20. Ooh, positive 21, right? Because we have a negative 3 times a negative 7, so that's a positive 21. Really good job catching the negative times a negative. So negative times a negative is a positive. Keep that in the back of your mind, okay? And the last one, we should have 3 to the 3 times negative 1, which would make it 3 to the negative 3, which should equal 1 over 3 cubed. So yes, these can seem basic if we're just doing one thing. It's when we start making them complex and have to mix them with multiplication and division. We got to remember all of our different properties that it becomes difficult. But our next step shouldn't be overly difficult. Hey, if I have a number raised to a power, I multiply my exponents. Guess what happens if I have a variable?
I
I feel like I'm missing something. Oh no, here we go. Are these the correct one? Do I have the correct ones up? Okay. All right, so it's going to the same thing as numbers, right? I have x to the 9th to the 3rd. What is that going to simplify to? Yeah, perfect. So if you're not sure what the multiplication is, just walk me through it, and that would be perfect.
Well, would it be the same thing then?
It'd be the same thing. Yeah, we're just multiplying our exponents. So I have a to the 2nd, which would equal a to the 14. You got it. Perfect. I'll do the next one. K to the 4th to the negative 2. That would be k to the 4 times negative 5. Did I say negative 2? I meant to say negative 5, which would be k to the negative 20th. I don't want negative 20, so I'll put a 1 over k to the 20th.
What do you do with the 1 when you, like, if you're doing a division problem?
Mm-hmm.
Does the 1 just, like, disappear?
The one on top?
Yeah.
It will stay there.
But you know,
So if I have like 1 over 4, it just stays there unless you put it in your calculator and it turns into a decimal. The 1 needs to stay there because that's as simplified as your top can get if it's a 1. Okay, let's talk about D. D's where it gets a little more complicated. We have CD squared to the 4th. Remember we distributed numbers? Remember when we had, let's review some stuff. Let's say I had 3 times x plus 2. We would take that 3 and distribute to both things, which would give me 3x plus 6. Do you remember that? You should, because we have a test on that, right? We had a quiz on it. We will have a test on that. Okay. When we have this power here, this to the 4th affects everything in here. So this 4 kind of gets distributed to both things. Yeah, bruh, indeed. So what we really have is we have c to the 4th times d squared to the 4th. That 4 affects both things.
so the 4, like, multiply?
It kind of multiplies. It's not quite multiplication because it's not a multiplication problem. It's a raising of power. So everything gets raised to the power of 4. So everything in here gets raised to the power of 4. So c gets raised to the power of 4, and d squared gets raised to the power of 4. But when you're raising a power to a power, you multiply. So this answer is going to be c to the 4th times d to the 2 times 4, which is 8. I heard it. And that's our final answer. So when you raise something to a power, everything that's in gets affected by that power. Yeah.
Why didn't c get raised to the power of 2?
Because that was just attached to the d. There could be ones where, so let's say c had a 3 on it. You can't see that. But let's say c had a 3 on it. Then I do 3 times 4, which would be c to the 12th. So you have to do what's already there. What's inside of this, notice how the squared is attached only to the d? That's the only one that's affected by it. So if I look here, do you see how the negative 2 is attached to the m? and the n is attached to that 8. When I do this multiplication, so when I bring this 3 to affect everything, that 3 is going to affect that 2, and it's going to affect that 8. But this 8 has no bearing on the m, and the negative 2 has no bearing on the n, if that makes sense. Let's go through this. So I should have this equals, well, I should have m to the negative 2 to the 3 would be negative 6. It should be m to the negative 6 because 3 times 2 is negative 6. M to the negative 6. And then we'll have n to the 8 times 3, which should be 24. Yeah. I would need to put in a fraction because Mr. Pabian is going to take a point off for this. Now remember, an easy thing to remember, if it's got a negative exponent, it goes to the bottom of the fraction. If it has a positive exponent, it goes to the top of the fraction. So this is going to be n to the 24th over m to the 6th. Is that making sense? Yes. All right, for our last one, what happens when I multiply a negative times a negative? Positive. It becomes a positive. It goes negative. Okay, so I have a negative times a negative, so I have negative 7 times that negative 4. So that should be a positive, right? And it should be a positive 28 is correct. All right, then I have a negative 7 times a negative 2. That should be a positive 14. Y to a positive 14. Both of those are positive, so I don't need to turn it into a fraction, and we are done. That's it if we're dealing with one thing at a time, right? We have one entity being raised to a power. Now, when I put a number in front of it, so the only thing we're adding now is I have a number in there now, right? But just remember, when I raise something to a power, everything in that parenthesis gets raised to that power. We clear on that? So if it's in parentheses, everything gets raised to that power. So when I see this first example, it says 3x to the 7. Are these in parentheses? Yeah. So that means everything must get raised to that 2. Okay? So what we're going to have is we're going to have this 2 is going to go to that 3, and it's also going to go to that x to the 7th. So that means we're going to have 3 squared x to the 2 times 7, which would be 14. I'm going to go ahead and do this because this says simplify the variables with the power rule. So we're going to simplify. 3 squared, is that 6? 3 plus 3?
Yes. No, 9. Oh, it's 9.
Why is it 9?
Oh,
3 plus 3 is
3
6.
times 3.
Oh, it's 3 times 3. So raising to a power is repeated multiplication. We know how to plug that in our calculator, right? So when we get to big numbers, might as well plug in our calculator. But 3 squared should be 9x to the 14th. Okay? Dylan, that sounded sarcastic. I'm sorry. Okay, are we good on that? Okay, yeah, Ethan.
Oh, never mind.
You sure? Okay, so our next one. Remember, the 3 affects everything. So I actually have 5 to what power? 3. And I'll have n to the 3 times 4, which would give me 12. Thank you. And 5 cubed is 5 times 5 times 5, which, careful, 5 times 5 is 25 times 5. Ooh. 5 cubed is 125. I think you added it. I think you did 5 plus 5 plus 5. It should be 5 times 5 times 5, which should be 125, n to the 12th. Take a little bit of time and do those last two, 15 and 16. Show me that you can do them. All right. Yeah, take that one off there. All right. So we should have did the... We should have did the 2 goes to the 10 and to the x. Well, that's going to give me 10 squared. X to the 2 times 7, which is 14. 10 squared is 100. X to the 14th. Good. If we do it step by step, this stuff shouldn't be difficult. It's when you start overthinking it. All right. Oh, come on. Go, go, go. Okay. All right. Remember, this of 4 affects everything. So we're going to have 4 to the 4th and w to the negative 7 times 4, which would be negative 28. Is not finished because we can do 4 to the 4th, which is 256. W to the negative 28, which still isn't finished because we have a negative. So we throw that to the bottom. And we have 256 divided by w to the 28th. All right, let's make it more difficult. Not much more difficult. If you understood this, you're going to be okay.
Wait, how do you do this over?
Okay. Shh. Let's look at number 17. Let's look at number 17. Does this 6 affect everything? Yes. So the 6 goes to everything that's in the parenthesis. So that 6 goes to the 2. It goes to the P. It goes to the Q. So we should have 2 to the 6th. P to the what power?
12.
Why 12?
Because you multiply.
Because we multiply, we got our 6 times our 2, which gives me 12.
Where does the 6 go after it's
Hang on. Let's finish and then ask questions, okay? All right, now, what's our Q power to? 30, because 5 times 6 is 30. Campbell, I think you said what happens to the 6 afterwards? You're done using it. You've shown how this power of 6 affected everything that was within, so you're done writing the 6. What looks like an 8?
Yeah, it looks like a very strange. Looks like a very poorly.
Guys, can we just singing? I got to hear what the question is.
Q looks like a very poorly drawn 8.
Oh, my Q. Okay. I have a cursive Q. Okay. So the only thing we have to do now is 2 to the 6th. That could be something our calculator does. I'm actually probably not going to be overly concerned that you do this. What did you come up with?
64.
You got 64. Did anyone else get 64? All right. So we got 64 P to the 12th. Q to the 30th. Hey, what I want us to do is I just want us to do 19 and 21. For time's sake, you guys are doing 19 and 21 following the rules, okay? Can we do that? Let's focus. We are doing 19 and 21. If you're confused on anything, ask a question. I should have realized that this 2 goes to everything, right? So I should have at the very least, even if I don't know how to simplify it, I should have been able to go, oh, that must be 4 squared. C to the negative 9 times 2, which is negative 18. And D to the 2 times 2, which is 4. Is that difficult, that step? I'm just taking a 2 and putting on everything and multiplying it if it hits a number. Hey, we can get most of the points there, okay? If I can't simplify that, can we at least do this? Keep that in mind when we do this one, because this one's more complicated than it looks, right? So keep that in mind. Okay, so I'm going to simplify this one, though, because I can go a little bit further, because I can do 4 times 4, which is 16. C to the negative 18, D to the 4th. If I need to get rid of this negative exponent, let's pay attention, it goes to the bottom, right? Everything else goes to the top. You know it? What do I do? Perfect. So we need to get away from having to write 1 over c to the 18 every single time. We need to get to the part where we can just go, oh, that just means it's on the bottom of a fraction. We write our fraction, everything goes on top except for negative exponents. Okay? Let's keep that in mind when we get to this one. We're now dealing with a negative 2. Negative 2 goes to the 5, so I should have 5 to the negative 2. The negative 2 distributes to that 6, which would give me k to the negative 12. Now, before I simplify this, how about I write the fraction correctly? That means anything with negative exponents goes to the bottom, and everything else goes to the top. Yeah?
When you do 5 to the power of -2, I don't know.
It should be 1 over 25. Because think about this. I'm going to rewrite this, okay? I'm going to rewrite this whole thing. Now, these both have to go to the bottom of the fraction, and I technically have a 1 out here. So the way I'm going to rewrite this, I'm going to write this as 1 over 5 squared k to the 12th. Did I get rid of both my negative exponents? Yes, I did. It goes to the bottom of the fraction. So that's going to equal 1 over 25 k to the 12th. Yeah, Gabby. How do you do negative exponents? You're going to type in a negative exponent. But what's easier, Gabby, is honestly, I don't use my calculator. I put a positive exponent in, and then I put it in the bottom of my fraction. So I'm probably not going to write 5 to the -2. You probably can in your calculator, but sometimes it gives you a decimal.
Yeah.
In that regard, just know it's 1 over 5 squared. So you have to be smarter than your calculator sometimes. Sometimes it's not that I can use my calculator on every single problem. But if you want to type it in, you can try 5 to the... Do you have a hat button? So make sure if you're plugging in your calculator... If I do it in my calculator, you got to do it like this. You have to open a parenthesis and put -2 and close a parenthesis in some of your calculators. You got 0.25? Oh, yeah, because it's 1 over 25. No, that's correct. You'd have to change that to a fraction then. You do have a button that changes it to a fraction?
1 over 25.
There you go, 1 over 25. But sometimes we need to be smarter than our calculator. If it gives a decimal out, change it to a fraction. Otherwise, know that... So sometimes we have to be smart in our calculator. If I can't do 5 to the -2, my calculator realizes it's 1 over 5 squared. That's why we know how to rewrite that stuff. So in case my calculator's not working right, I can write it as 1 over 5 squared. Okay. Let's take a peek at some ones that use multiple things. Pay attention, ask questions, okay? Remember, PEMDAS is parentheses first, then exponents. So you need to deal with your exponents before you do anything else. So do you notice how we have a power to a power? We have to worry about that 2 first. So the first thing we're going to do is we're going to take that 2 and make sure see what it affects. Yikes. The 3 doesn't get distributed to the 5 because there's no parentheses. The 3 is just attached to the W. Only if parentheses happen do I have to kind of distribute it to everything, okay? All right, so I should have, 6 squared? W to the
16.
To the 16th times 5W cubed. Now, I should simplify this, right? The 6 squared? Because we'll simplify any power we can because we do exponents first. I can do 6 squared, which is 36. W to the 16th times 5W cubed. Now we're done with the exponent, right? We've already distributed the exponent. Now we're to multiplication. And when we do multiplication, we multiply the things we can. Can we do 5 times 36? Yeah, we can even plug it in our calculator just in case we're wrong. Did we get 180 out?
Yes.
Do we agree with 180? Okay. 36 times 5?
Yes. Oh, and then do we add the 2 W's?
Am I wrong?
Yes. You multiply, you add the
Oh, yeah. Listen to Sean. What do I do?
If you multiply, then you add the
Exponents? Yeah. So are we clear on the 36 times 5?
Yes.
Are we good with being 180?
I got it.
What'd you get?
Oh, I get it now.
No, Kyra, what'd you get?
What? Oh, no. I was figuring out what I did.
Okay, but you got it?
Yeah.
Are you sure? Okay, so we have 180. And then Sean says make sure you add your exponents. Are W's both my bases?
Yes.
So I can multiply them by doing W to the 16 plus 3, which is W to the
19.
19. So notice we're just chunking things. We're chunking things into things that we know how to do. Try not to do multiple things at once. Try not to multiply and divide and raise exponents all at the same time. Do them bit by bit. So if we look at this first thing here, this next one, is everything being raised to 2? Because there's a parenthesis there. So that 2 goes to everything that's in here. So that 2 goes to everything that's in there. So that 2 goes to the 5. It goes to the P. It goes to the 3. It goes here. But here's my question. I did something wrong. I made you do it 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 wrong. So pay attention. You'd actually get the right answer, but you're making your life a little more complicated. How does PEMDAS work?
You do the
Exponents first. No,
Parentheses first.
Dude, it has a P first.
Is there stuff that's in the parentheses that I can simplify? Yeah. Okay. Guys, regroup. You would not have got the wrong answer because I did distribute to everything. It just would have been a more complicated problem, but you'd still get the right answer. What I'm going to do instead is, PEMDAS says do parentheses first, so I'm actually going to do this multiplication first. And so I should have, what's 5 times 3? 15. What's p to the 4th times p cubed?
P to the 12th.
Careful.
7.
P to the 7th, because multiplication's adding. So we have p to the 7th. Make sure you bring your parentheses back down, and then we square everything. So I took what's in here and simplified it before I squared it. Makes your life a little bit easier.
Since the whole answer is 30.
What'd you get? You got to the... Oh,
P to the power 49.
I don't think it's 49, though. I think you did a little bit. I think you did 7 times 7. Okay, so this 2 goes to everything, right? 2 goes to everything, so I should have 15 squared. P to the what power? 14. I think you did 7 times 7 instead of 7 times 2. So that'd be to the 14th, which happens because it feels like I'm raising it to a power where I do like the 7 times 7, but it is not. This is multiplication. What's 15 squared? Did anyone plug that in yet? 225. P to the 14th.
He did it, guys.
All right, we're just going to do one more together, okay? And then we can work on our homework. Because I would like to give you like 10 minutes to work on it, but... I do want to say, I always have plans for you guys to have a lot more time to do your homework, but we spend a lot of times me waiting for you guys to stop talking, right? So we eat up our time. And I know it's not everyone. I know some of you just want to do the work, and I'm glad some of you can actually start the homework while people are talking. But some of us just need to refocus and make sure that we are taking away from other people. When we're talking and distracting the class, we are taking away from other people in this classroom. So try to take some ownership of that. All right, do we see any of these 4 we'd love to do that you're just like, I don't know how to do that? Yeah.
27.
You want to do 27? Let's take a peek at 27. Now remember, when I'm dealing with division, I need to simplify the top and the bottom. Is there anything I can do to the top?
No.
There's no multiplication. There's nothing happening up there. Can I simplify the bottom? Yes. Now pay attention when we simplify this bottom. We are going to distribute this 3 kind of to both things. Now be careful how I write this. I'm going to have 56k to the 28th because I didn't do anything there. I have negative 2 cubed, right? Remember, when you have a negative raised to a power, you should put it in parentheses. So I have negative 2 cubed. K to the...
24.
How did we get 24?
Oh, wait. I'm full.
No, I don't disagree. How did we get to 24? We do 8 times 3, which gives me 24. So we have negative 2 cubed, right? So that's negative 2 times negative 2 times negative 2. When we're plugging this in our calculator, make sure you use parentheses. But negative 2 times negative 2 is a positive 4. Let's just sit over here. And maybe we're just going to sit there for a while, because... All right, so I have negative 2 times negative 2, which is a positive 4. What's positive 4 times a negative 2? Do we agree with negative 8?
Yes.
Okay, so that should be a negative 8. So we should have 56k to the 28th over, we said negative 8k to the 24th. Are we done simplifying on the top and bottom?
No, sir.
Well, on the top alone and the bottom. Yeah, we're not done yet, though, right? We're not done. We're not done. Okay, let's finish this off. If you need to in your calculator, just see what's 56 divided by 8.
Negative
7.
7? And so we have a negative 7, right? Because we do have the negative. I asked it with positives, but we would have a negative 7. Yeah.
We would have negative 7k to the 4th power.
K to the 4th power. Do we agree with k to the 4th power? Is that with a question mark? So I'm going to say it with a question mark as well.
Yes.
Do you agree that is k to the 4th?
Yes.
28.
Because it'd be 28 minus 24, which gives me to the 4th. Do I have any negative exponents? No. So are we done?
Yes.
Yeah, we're done.
Homework time.
Now it is homework time. It is homework time. If you would like the rest of these answers, I'm going to put them up real quick. If you'd like to just copy them down in case you want to check them later. But we get some time to do our homework. I know some of us have been working on other problems that were on here, so I am going to take a picture and show you my work.
Let this move.
So maybe make sure we try it, right? Try it first, don't copy it. Try it.